7th grade, lesson 8.4 is angle relationships, and you'll learn several vocabulary words. There is a set of notes on this that have them broken down, or you might want to flag this page 251 and the next one with highlighted vocabulary words until they get stuck in your head a little bit better. Let's get started on talking about several of these angles. Okay, and they start by talking to us about congruent angles, and you'll see that there's a relationship between different angles. What they mean by congruent angles is these are angles that have the same measure. And a couple of things I want to point out to you. You'll see them symbolize the word angles like that, or you'll see me sometimes symbolize it like that angle. So when I write angles, I just abbreviate it as one of those two symbols. Angles, and you'll see over here that's what they did. This means the measure of angle 1, the measure of angle 2, the measure of angle 3, and so on. Congruent angles have the same measure, the same number that represents them, and you'll see the congruent sign looking like this. It looks like an equal sign with a squiggly line over the top, and that means congruent. So same value. Okay. This part of the lesson, they say, go ahead and use a ruler, draw a pair of intersecting lines, and then label each angle from 1 to 4. So I'll do that now. Okay, so I've drawn two intersecting lines. They intersect here. I've labeled them angle 1, angle 2, angle 3, and angle 4, like they asked. Then they tell me to go ahead and measure each angle with my protractor. So if I laid my protractor down on here, I would put the center of it here and line up the bottom part of the protractor with this line. I would start at 0 and move my way across. And let's say I measured that and I came up with 160 degrees. Then I measure the same over here. I line up, let's say I want to do angle 4. I line up my center little dot and the bottom here. Since this line points off this way, I start at 0 on this side and go up, and let's say I ended up with 20 degrees. I would do the same for all of these angles, and when I measured them all, I got 20 degrees on angle 2, and I got 160 degrees on angle 3 when I measured them. So they asked me to fill in the information. The measure of angle 1 is 160 degrees. The measure of angle 2 is 20 degrees. The measure of angle 3 is 160 degrees. The measure of angle 4, 20 degrees. Then they want me to add some of them together. The measure of angle 1 plus the measure of angle 2. Angle 1 plus angle 2, 160 plus 20 more is 180 degrees. The measure of angle 2 plus the measure of angle 3, measure of angle 2 plus the measure of angle 3, 160 plus 20, 180 degrees. The measure of angle 3 plus the measure of angle 4 put together, this whole angle, 160 plus 20, 180 degrees. And the measure of angle 4 plus the measure of angle 1. Angle 4 going from here to here plus the measure of angle 1. It forms a straight line when they were put together. 20 plus 160, 180 degrees. And if we all did that in the class, all of our intersecting lines, you would notice everybody kind of got the same thing. Our angle measures may not have been the same because maybe our lines were drawn up differently, our intersecting lines. Maybe they weren't as thin here and wide here. Maybe they drew them differently. But what you would notice is that these opposite angles, they're the same, they're congruent. This opposite angle is congruent, same value. And you would notice when you add the two angles next to each other, you would get that straight line, which is 180 degrees. This one plus this one, 180. Everybody would get that, right? If I did this angle plus this angle, that's a straight line, 180 degrees. This angle plus this angle, 180 degrees, straight line. Pretend that's a straight line. So you would have all that. This angle congruent to this opposite angle. This angle congruent to this opposite angle. So no matter how they drew it, as long as they measure correctly, they're going to have this part all be the same, and you're going to notice that their measure of angle 1 and 3 is congruent, and their measure of angle 2 and 4 is congruent. So that was just kind of the explore piece to see that that works out. And so in the explore activity, I had mentioned the opposite angles from each other. The word for that is called the vertical angles. Vertical angles are the opposites when you have two intersecting lines. And if you have two intersecting lines, this line intersects with this line. Then the ones that are touching nose to nose, like if this was this angle's nose here and this angle's nose was this right here, the ones that are touching nose to nose, almost like they're touching in a mirror, they are congruent. They will be the same value. So these blue angles are congruent to each other. They are vertical angles and they will have the same measure. Same with these red angles. This little red angle touching nose to nose here with this little red angle, that is a vertical angle and it is congruent. They are congruent to one another. They will have the same measure. So vertical angles, opposite angles, nose to nose in a mirror, when you have two intersecting lines. And those two angles, those opposite angles, will be congruent. Okay, adjacent angles. Adjacent means next to usually. Like if you live in an apartment, you live adjacent to somebody. So I call these the next door neighbor angles. These are a pair of angles that share a vertex being the meeting point, the corner, and they share one side but do not overlap. So for example, I have angle A here and angle B. They are like neighbors that live in an apartment and they share a wall. Of course, their wall doesn't go into one or the other's apartment. It stays kind of in between them. It's their barrier between each other. So they share their angle point and they share one wall. Those are adjacent angles. Complementary angles are when you have two adjacent angles next to each other, and if you were to add their two measures together, they add up to a right angle, a 90-degree angle. So whatever this angle plus this angle is, if it adds to 90 degrees, they are called complementary angles. So they're two angles that when added together will equal 90 degrees. Okay, and similarly, supplementary angles are two angles that are, and when you add the measures together, they will equal a straight line, a total of 180 degrees lying flat. So these two seem to be the most often confused ones that people confuse with one another. And so the best way I've come across for helping me remember and some of my students remember which is I've underlined the P there and the double there. So if I'm looking at whether a complementary angle or supplementary angle is the 90-degree one, this P is, there's twice as many P's there as there are here. And 180 is 2 times as many 90 degrees is. That's not even a word, but you get the point. So this one is the larger value, the 180 degrees. That's how I remember. It's got double the P. So it's the doubled amount, 180 degrees. That's what's helped me remember. So if that helps you, then great. Okay, for example 1, they have us try and find certain angles that go with those vocabulary words, starting with the vertical angles. Remember, vertical angles are the ones that are congruent. They're touching nose to nose in the mirror, right? So if I look at the way you read these angles, by the way, is that F point is the middle letter. So this angle here would be angle AFB or angle BFA, doesn't matter which direction. This angle here would be AFE or EFA. That middle point is always the middle letter. This is angle EFD or angle DFE. This angle is a 90-degree angle because it has this little bar, this square mark here saying that's a 90-degree angle. CFD or angle DFC. This one is 50 degrees, BFC or angle CFB. So that's how you read those. And they want us to find at least one pair of vertical angles. So we're looking for angles that would be a same measure, So they need to look like the same measure, and they are two intersecting lines that are opposite each other, like they're nose to nose in the mirror. So if we look at this intersecting line and this intersecting line, opposite of each other are these two. Also, this one all together with this one is also a vertical angle. So we could say angle AFE is vertical to angle BFD, the whole thing, or angle BFA is vertical to angle DFE. So this would be a vertical angle and would have the same value. They say name a pair of adjacent angles. Adjacent, remember, are the ones that live next door to each other but share the same wall. There's a whole bunch of choices here. CFD is adjacent to DFE. They share this wall. EFA is adjacent to AFB. They share the same wall. So a BFC is adjacent to CFD. They share the same wall. Doesn't matter their values for adjacent angle. It's just that they are next door to each other sharing a wall. Name a pair of supplementary angles. Supplementary, remember, has two of the letter P in there, so it's double the amount. So we're looking for two angles that when put together give us a 180-degree angle, a straight line. So here's a straight line. So let me just put two angles together that make a straight line. I can do AFE here plus over here angle EFD. If I add those together, they will create a straight line. I could do AFB as long as I do BFD, this whole amount over here plus this amount, two angles that add to 180 degrees. Complementary angle would be two angles that add to 90 degrees. Well, here I know this line and this line make a 90-degree angle over here, right? That means that this is also a 90-degree angle over here. So CFB plus BFA together would make a 90-degree angle. So that would be complementary. And what's kind of cool about these is you can see them as kind of puzzles here. There's a lot of pieces of information. I know if I were to say find as many of these angles as you can, given just this information, and they've only given me 50 degrees here. Oh, and they also gave me that this is a 90 degree. Well, I can use that to my advantage. If this is a 90-degree angle, and I've already used 50 degrees of it, then 90 minus 50 is what's left. So now I know that's a 40-degree angle. And then I already know this one over here is 90 degrees, so I'm going to put that. Then I know that this angle is vertical to this angle, and I also know that vertical angles are congruent, so there's 40 degrees there. And I can do this angle one of two ways. These two angles added together are vertical to this one, nose to nose in a mirror, so they're congruent. So I could just add those together for 140 degrees. Or I also know that this is a straight line, and this angle is supplementary to this angle, meaning both of those added together will form that 180-degree straight line. So I can take 180 degrees, subtract 40 from it, and get 140 degrees. So with just that little bit of information, they gave me one number, or I guess technically two numbers. I was able to find the remainder of my angles. But what if they do this to me? What if they throw a variable at me on one of my measures? So they tell me that angle EHF and angle FHG form a straight line. By now we can recall that a straight line is 180 degrees. And I know that if I add this angle to this angle, that completes that straight line 180 degrees. So I'm going to add them together. 2x added to 48 equals 180 degrees. And so now maybe this is looking a little bit familiar. This is a two-step equation, and I just need to solve for the variable by using inverse operations. So I will subtract 48 from each side of the equation. That gives me 2x equals 132. Now x is being multiplied by 2. I undo that by dividing by 2. 132 divided by 2 is 66. So I now know that x is 66 degrees. And I know that this is 2 being multiplied by that for that whole angle, which is 132. So the measure of angle EHF is 132 degrees. So you'll just use your knowledge of solving for variables to solve those. Let's look at another one like it. Okay, I'm looking at a right angle here, and I know it's a right angle because they put this little box here. So the total is 90 degrees. They are two angles that add together to make 90 degrees, complementary angle. So I would add this angle to this angle measure, and that together would equal 90 degrees. So I have 35 plus 4x plus 7 equals 90 degrees. So I just took this 35, 4x plus 7, added them together, and I know they will equal 90 degrees. Well, first let me take care of these like terms. These are like terms. Let's put them together as a positive 7 and a positive 35 for a total of 42. Now I can do inverse operations to isolate my variable x, starting by taking 42 away from this side and from this side. That is going to give me 4x equals 48. X is being multiplied by 4. Inverse of that is divide by 4, both sides of the equation. That gives me x equals 12. So this is really 4 times 12 plus 7. And of course, 4 times 12 is going to give us 48 plus 7. And 48 plus 7 is going to be 55. And so what I know is now that I've discovered what x is, and I plugged it in for that, I went ahead and solved for that. I find out this angle YXZ is 55 degrees. ZXW, we already knew was 35. It should, added together, be 90 degrees, and it is. So that's pretty much what this lesson works with. It adds new knowledge in terms of vertical angle, adjacent angle, complementary angle, and supplementary angles. Complementaries, two angles that add to 90 degrees. Supplementaries, two angles that add to 180 degrees. And just recognizing vertical angles being congruent and those sorts of things. And so it adds that new information, but it also utilizes tools that you've used in the past to solve the unknowns if you are given unknowns. So I think you'll do well. It takes a little bit of practice, but once you have the hang of it, it's not too bad. To me, it's like doing puzzles. These I don't mind doing. I enjoy them. It's like finding that missing piece is like a puzzle. So I hope you enjoy it too.